We'll solve this today's LeetCode problem. This is LeetCode easy. Let's see what the question is. Sum of all subset XOR totals. So here we have given the XOR totals of an array is defined as the bitwise XOR of all its elements or 0 if the array is empty. Okay. For example, the XOR total of the array 256 is 2 XOR 5 XOR 6 is equals to 1. Nice. So we have given an array nums. Return the sum of all XOR totals for every subset of nums. Okay. Subsets are with the same element should be counted multiple times. Okay. An array is a subset of array. Okay. So what is a subset? So if we, what is subset? So subset is something that it has 2 to the power n elements. It has 2 to the power n elements. It's the combinations of all the elements present in array. Right. Suppose here a, b, c, d elements are present here. So how many subsets can be generated? So it's 2 to the power 4, that is 16. How? So first is empty subset, right? Second is a, then then b, then c. Okay, this is the longest, so let's take it as abc only. Okay, so this should be 2 to the power 8. 2 to the power uh, 3 is 8, right? Because 16 is very long. So you will understand from this example also. So abc also, now this a can combine with this b, then also with c, right? So ab, then ac, right? Now this this b can combine with c also, then bc, then okay. Now we have formed one elements in each subset, then two elements, then we form three elements, then a, b, and c, right? So this cba is also valid, but this and this is same, right? Because this is only a permutation, right? So this and this is same, so we will only consider one, right? Once only. So this is how the eight combinations of elements are present. So this is eight subsets of this. What is subsequence? Subsequence is something which do not include this empty subset. Subset minus one, right? Exclude empty. This empty subset, exclude empty subset, exclude empty, right? So this is the subsequence. But here we need only subset, so this is the subset, right? So we need to find the sum of all XOR totals of every subset. It means we need to take XOR of each subset, XOR of all elements of each subset, and add them, right? We need to just add them. So if you see here 1 3, in 1 3, how many subsets can we form? 2 to the power 2, total elements is 2, so 2 to the power 2, that is 4. Which will forms? So 1 can be possible, 3 can be possible, 1 3 can be possible, right? So this is empty subset. XOR of empty subset is 0, right? One XOR of one element is 1, XOR of three elements is 3, XOR of 1 and 3 is 1 XOR 3, which is equals to what? If you see 1 0 and 1 1, what will be the XOR of this? XOR property says that 0 XOR 1 is equals to 1, 1 XOR 1 is equals to 0. This is the property of XOR. It's the properties of XOR property. This is the XOR properties, right? So we will see this here, right? We will see this here that 1 XOR 1 is 0, so this will be 0. This 0 XOR 1 is 1. This is 1. So which number his binary form is 1? So the 1 XOR 1 is 1 XOR 3 is, sorry, this 1 XOR 3. This should be 0 XOR 0 1, not 1 0. For one permutation, this is 0 1. So 0 XOR 1 is 1 and 1 XOR 1 is 0. So it becomes 2. So what we need to do? We need to add all the XOR of subsets. So answer will be 0 plus 1 plus 3 plus 2, which is equals to 6. Like you can see here, the answer is 6, right? So we need to find all subsets XOR. So I see a constraints here, the nums dot length is 12. So how many subsets can be formed? 2 to the maximum. How many subsets can be formed? 2 to the power 12. The maximum subset which we can form which we can go maximum subset is 2 to the power 12. It's something like 1e4 or something, 1e4 or greater than 1e4 but less than 1e5, right? This 2 to the power 12 is greater than 1e4 but less than 1e5, less than 1e5, right? So this constraint is very small. If the constraint is very small, it means I can form every each and every subset for this. I can form each and every subset for this and find the XOR of all elements and include in my answer, right? I can do that, na? So here we need to find the subset of all elements. So for finding the subset of elements, for finding the subset of all elements, what we need to do, what we need to do. So if you see here, what are the subsets? If 1 3 is given, so the one thing is that one thing we don't include anything, then we include 1, then we include only 3, then we include 1 3, right? If you see here ABC, we include empty, we then include A, then B and C only, then AB, then we removed B, we only include AC. Now for B, we exclude A, then we include only BC. For ABC, then again ABC. So if you see, we are taking or not taking, right? If you see here, if I choose, if I can choose this, right? So we have option of uh, we have option here that either I can choose this or I can not choose this, right? So A is included or excluded. So if A is included, so this A will be forms will be pakka form, right? And if this A will, and after this B, we have option of choosing B, right? So if you see here like this, A B C, A B C. So the first thing is either I choose A or B or C, or either I don't choose. So the the first thing is that I choose, I don't choose A, right? The first thing is I don't choose A. If I don't choose A, this will be empty, right? The second thing is I can choose A. If I choose A, this becomes A, right? If I don't choose A, what are the options after that? I will move to this B part, then I can choose B or not. So if I don't choose B, it will be empty again. But if I choose B, it will give me B, right? Again the same options. Either I can choose C, because here it has 0 now. This is at 0, this is at 0, this is at 1, and this is at 2. So either I can choose this or not choose this. Okay, just give me a sec, right? Either I can choose this or not choose this, right? So either I can choose C or not. So one thing is I don't choose, the second thing I choose, right? So it will include C. The same options is with this B part. Either I can choose the Cth part, either I can choose the Cth part. So if I don't choose, then it will become B. If I choose, it becomes BC, BC, right? The same thing goes with A, this part. If I don't choose A here, if I don't choose A here, right? If I choose A here, then I have again two options. The first option is, the next option is either I can choose B or not choose B. If I don't choose it, it becomes A. Otherwise, if I choose B, it becomes AB. Again, I have two options for that. This again, I have two options for this. Either I can choose this C part again or not choose this. So if I don't choose this, this will become A. If I choose this will become B, right? This will become AC. Now again for this part, the same thing happen. Either I can choose C or not. If I don't choose C, this becomes AB. This becomes AB. If I don't choose C, right, this becomes AB. Or if I choose, this will becomes ABC. So and if you but and if you see here, we got all the elements. How? See, how many elements should be there? 2 to the power 2, 2 to the power 3, right? It means 8 elements. And you see 0, 1, 2, there are 3 levels. At this level you got 8 elements. And if you see, all, we have got all the subsets at leaf nodes. At leaf node, see this empty a b c ac bc ab abc. I got all the things at last, right? So this is how we will choose. Either I can take or not take. This is how we will form. So the approach will be what will the approach? I have two options. Either I include the current element or exclude the current element, and in both of cases I will move forward to next element, right? Either I choose or not, I will move next forward, right? Okay. Now this is how we will form, but how we will maintain this XOR operations. So if you see here, if I choose, if I choose, I will take XOR with the. I will also maintain a XOR with it. This is XOR. This is XOR, right? I will also maintain a XOR with it. If I choose, I will take a XOR with A. If I don't choose, I will don't take a XOR with A. Simple. So if I choose this A, this is empty. So I will the XOR value is 0. If I choose this, the XOR value is what? XOR dot B. XOR B. Right. This is the XOR. Here XOR A. If I choose B, the XOR will be becomes A XOR B. Otherwise, if I don't choose, the XOR A will become XOR A. This is XOR A. Right. This XOR becomes XOR E. So if I choose AB, this XOR A XOR B is same. Otherwise, it becomes XOR A XOR B XOR C, or you can take as X. It, okay. So this is something, and initialize with X with 0, because you know already that A XOR something elements with XOR with 0 is same as element, right? So this is the also properties of a XOR. Let's write it here, right? And also one property is here that A XOR A is 0, right? So this is how we will form, and if I include, then this becomes this, right? So this is how we will and at last I get all the XORs. So what will I do? I will take summation of this, then at this position this is X, this becomes X XOR Z. Similar at the similar approach, this is X XOR B, X XOR, and this is same as X XOR B XOR C. If I write here, right? So if you see, I also got taking. I also uh, if I go with the XOR including point. So at last I am also getting this XOR value as XOR A at last. Same with as this subset value. So this is how we will solve. So include, and the what is the base conditions? The base condition will be the base condition. So and the XOR value and XOR operations will go simultaneously with with chosen element, with included element, right? And base will be, so base condition will be when uh, when I am at last position, when I'm out of bound, then I will store the answer and return, right? So let's see, we will see this implementation. You will be definitely understand more than enough. So what we need to do? we need to first we think first we need to this is the index value, then we need to also pass this nums and also the XOR value, right? This XOR value is x, so let's initialize with x equals to 0, right? Now what we need to do, we need to we will make XOR operations. So this is index, this is nums, and this is x, this is XOR. So x represent XOR here. So what are we passing here? Index, nums, array and XOR, right? This we are passing. Now first thing, either I can include or I can exclude. So if I exclude, this is for excluded part. If I exclude it, then we don't XOR it because the elements I have don't, so XOR will be the same. But if I include this, if I include this, it means I need to XOR with this current element. This is for include, right? And this is excluded. So if I include, I need to take a XOR with x. Otherwise, I will simply pass the same XOR and iterate in I plus 1, right? And what when will after that I will just return. So what will when will this loop when this recursion will end? When if I is greater than equals to n, then okay, if you see, whenever we get on last elements, we get in this tree the XOR values, all the XOR values. So I need to sum this because I have already XORed all the subsets of here, the XOR C, XOR B, XOR B, XOR C. Because if you see B is C is subset and its XOR values at last. So it means the X value has all the subsets XOR, right? So I need to just mark this a store in my answer to sum for summation because I need to sum of all the XOR totals, right? And return from here simply. Okay, I need to also define answer here. So I will just define an answer 0 and just I need to return this answer from it. This is a void function, so I will not return this. I will just return answer from here, right? This is a void function. So if you see what I have done, I have just excluded or included and just pass answer plus x and return it because all the nodes, all the answers will be at my last elements and I just need to take a summation of all that, right? So this is how we will solve. Let's run it. Okay, run it. So we have passed the sample case. Let's submit it. Yeah, we have successfully passed the sample case. Successfully passed the submission. So what will the time and the space complexity? So if you see the time complexity is what we are moving. We have two options here. Either we take or don't take. So we have two options and there are n elements. So for every elements we have two options. That will be 2 to the power n for sure, right? That will be 2 to the power n for sure. And for every elements, I need. So for every elements we are have two options at 2 to the power n and we are just calculating along with that. So the time velocity will be 2 to the power n. And what will the space complexity? The space complexity will be O of 1 for auxiliary stack space because we haven't taken any extra spaces. So O of 1 for auxiliary stack space, and O of n for recursion stack space, right? Because we need to move a recursion for each and every element. So that will be O of n, right? So this too will be the time and the space complexity for this problem. But if you see here, the constraints are very low. So this is the 2 to the power n will be not much value, so we can do this. Okay, so this is the recursive part, right? So this is the recursive part. So how will we do iteratively? So if you see here, so if you see here, this 2 to the power n and 2 to the power n is what? Suppose we have a b c, so 2 to the power n is 8, right? So it means if I So if you start taking the help of bits, so if I take help of bits, can we do this? Let's see. So 2 to the power 8 is, it means what? It means from 0 to all values, 0 to 15 value. 2 to the power 8 is 0 to 7. They are total elements. So if I start taking bits of all this, so for 0 is 0, for 1 is, for 1 is 0 1, for 2 is 1 and 0, for 3 is 1 1, for 4 is, for 4 is 1 0 0, for 5 is 1 0 1, for 6 is 1 1 0 and 1 1 1. This is the nomenclature for every element. So if you see here 0, and this is ABC, this is ABC, right? Okay. So if you see here for 0, how many elements can we take? 0, because it is 0. So it is an empty subset, right? Okay. For 0 1, and this is at position 0 1 and 2. This is the position of ABC. So we will, so whenever we get a 1 at the position, we will include only that position elements. What I mean? If you see here, from 0 to 7, I have written all the binary numbers, and what I'm telling that the number which, if I suppose this is one element, so the number of ones at position, I will take only that position. What does it mean? So for this 0, this is nothing. For this 0 1, at this position is 0, and this position is a, so this will include a, right? This is the second part, and this is 0 and this is 0, so I will don't include any of this, so I will just include a. For 1 0, for 1 0, so for 1 0, this is at 1th position, so I will include this 1th position, not 0th position, because it is at 0, so I will include only b. Again for 1 1, 0 and 1, so that will include a, b, right? Because in bits we see the elements from right to left, right? So this is 0 1, this is 0 1, this is 0 1, this is 0 1 2, this is 0 1 2, right? We see right from left. We are seeing, we are seeing right to left in bits, right? This is what we are seeing. We are seeing right to left in bits and left to right in array. This array, this ABC, right? If you see here 1 1 0 1 0 0, 0 at 0, we don't take a, we don't take b. Then at third position, that second c is included because here is 1, so I will include this c again. If you see 1 0 1, 1 is included, so I will take a. At bth position there is 0, so I will don't take b, which is 1, it is c. So this, if you see here, we are getting each and every subset. We are getting each and every subset, a b c. So if you see here, we are taking each and every subset. This is total 8, and we get all the 8 subsets here. So how we will do that? How we will do that? So what I need to do? I need to iterate from 0 to 2 to the power n minus 1, including. So to the power excluded. This should be excluded, and take and take. I need to take for each and every position. I need to check, and I need to check that for current value from this 0 to 1, current value from which current value which comes from this part 0 to 2 to the power n, from 0 to 2 to the power n, that at which position, at which position it has a set bit, it has a set bit, right? because if it has a set bit, I need to include that index. So that will I will include it, right? So what I need to do, suppose I have taken so suppose in this case I take uh, this 5, right? I include from 0 to 1, it's 5 comes. So 101, it's a binary set, right? It's a binary representation for 5. So what I need to do, I need to iterate in whole this, and what I will check, I will check that this a, so at this position, this 101, this for 101, that this 101 and ones are one at the position of the first position, it is 0 position. So 2 to the power is 0, 2 to the power is 0, first position is was 0. So is this and is this have 1. So for checking the bits, set bits, we need and, because if 1 and 1, if 1 and 1 is here, it will give 1. But if any value is 0, if any value is 0, either left side or right side, it will give us 0. So for checking set bit, I can do this, right? I can do this, right? So if both is 1, it means the value can be taken. If the both is 1, it means the value can be taken. So 2 to the power is 0. What is 2 to the power is? It is 0 1, right? So it means at 1th position it is set. It means I can take this. I can take this. A can be included. Same for 101, and for second element 2 to the power 1. It is 101 and 10. So this 1 and this 0 is not set. This 1 and this 0, it is not set value. So we are not taking this 1 to the 0 and to the power 1. We are just shifting. If you see here, we are just shifting this value by this. So if you see here, this 1, we are shifting just this like this. So this is for shifting in the left side. It's the same as 2 to the power j. So that's what we are doing. The same as 2 to the power j. You need to just remember this. So 2 to the power 1 is here, and this is becomes 0. So we will not include this. So this is 0. So we will not include. We will not include. Again for 101, the second position is, oh sorry, this should be and 101, and the second position is 2 to the power 2, which is equals to 101 and 100, 100. So if you see, this one and this one is forming, so I can include C. So I will take this C. So A C is included. So this for fifth element, A C subset can be found. So this is high. This is how we will find every subset. So whenever I get a value, I will take a XOR, right? So along with this, I can take also a XOR, right? So I will take a XOR along with it. So if X is 0, and whenever I get element, suppose I get A, so I will take X XOR A, XOR A. I will take XOR A, XOR C, and at last I sum all these values, right? So this is how we will solve this problem, right? Simply. So let's implement it. You will get a clear picture of that, right? So instead of this, what I can do, let's remove this. Now this should be removed. Okay, this can be passed at 0. Let's now initialize this 0, answer 0, and also I need to take n nums dot size. Now I need to iterate from 0 to 2 to the power n. So I've just told you that you can write, 2 to the power n, where, yeah, this one's less than j, it's 2 to the power j. It means the value which is at here, we can, what does it mean, that the one position is shifted to this jth position, right? So one is at, suppose the one this is the one, this is the one, 0 1, this is the 1. So this is represent 1. So when I write 1 left shift 2 or 1, it means it one is left shifted to one position at this position, so it becomes 2 to the power 1. It means 1 is shifted to 1th position, one position in the left side, right? This is the same value. So if I want 2 to the power n, it means I can write 1 less than n. I can write now because n is 1 is position shifted to n position, so I can, this is the same as 2 to the power n. So this is same as 1 less than n is same as 2 to the power n. Right. Now, for each and every element, I need to take the subsets. So I will again iterate in this element and need to find that which element, which position is a set bit, which position is set bit. So I will, what I will take, I will see that at this position, and after shifting it with 1 power j, if it is a set bit, if it is a set bit, if at this position in I is in ith element is a set bit, then we can include it. So including it means here that I need to XOR with it. So I will make a XOR value 0, and I will just include, I will take it just a XOR to this element nums j, because this is the element in index of that, and this should be the included. And after this completion, I will just include in my answer this x part. Right, it's the same thing, na? That for including element, I take a, if a is included, then I will take a XOR, because ultimately I don't need to find this AC. I need to find this XOR elements. So this X XOR A XOR C for a current, after the subset part. This is for generating a subset, and this is for a subset nums index. So after that, I need to include in my answer, and I will just return this answer. Right. If you not able to grasp it, just do the pen and paper, start pen and paper, and write on pen and paper and start making this, you will understand it, right? So let's run this. uh, this should be num sort size. Yeah, we passed the sample case. Let's submit it. We have successfully passed the all test case. So what will the time and the space complexity? This will be more fun, right? So if you see here, we are iterating from 0 to 2 to the power n. So this is 2 to the power n, right? And for each and every element, I need to iterate in whole of the array. So that will be again n. So that will be O of n, for O of 2 to the power n into n. That's will be the space time complexity. And what is the space complexity? So we are not taking any extra spaces, and there is and also we have successfully removed the extra recursion stack space also. So that will be O of 1 only. Right. So this is the time and the space complexity for this problem. Hope you will understand it. So thank you so much. So if you understand, okay. Now what we will do is 2 to the power n into n. Right. Now can we further optimize it, because it is an easy problem? So don't you think uh, it should be more optimized? Let's see. We have given a XOR values. So if you see XOR properties here, so XOR properties are here that the same element XOR with a is a, just different elements is 0, right? This is the XOR properties. Let's see what if let's take an observation for every element. So suppose in this 516, this is 516, right? So suppose this is given 516. So 5 binary representation is 101. 6 binary representation is 110, and 1 representation is 001, right? So if you see, it's and its total summation of XOR of all the subsets, it's 28, right? This is the 28. So for 28, what's the binary presentation? So the for 28, the 28, it is 1100. In this part, in this part, if you take the OR of these elements, OR of this, so this is at 1 1. Okay, this is at 1, this is also at 1, and this will also be at 1, right? Because taking XOR of, taking XOR of all the elements, right? So sorry, OR, OR of all the elements. So this is an OR of all the elements here. This is OR. So this is 1 1 1, right? So if you see here, this one and this one is similar, don't you think? Why? Let's take another example, 1 and 3. 1 3. Why I'm showing this? Because I need to prove something. I want to prove something. If I take all of this, this is 1 1 and 1 3. So answer is 6 here, which is 1 1 0. So if you see here, 1 1 is same as this one. Are you observing something, right? And what and how much zeros will be left here? How will we define? It's the 2 to the power n minus 1. How can say that? So if you see here, if you observe here, this part, right? Each element is present how many times in this subset? Suppose A is present at count of A, count of subsets include A. How many there are? 1, 2, 3, 4. This is 4. Same for B. How many are there? 1, 2, 3, 4. Same for C. How many are there? It is again 4. 1, 2, 3, and this is 4. So if you see, there are total 8 subsets, and each element is present in the subset 4 times. So if you see, each element, here is the observation that each element is present. Let's write this here. Right. Let's remove this and let's write this here. So each element is present at each element is present 2 to the power n. It's the total number of subsets by 2, which is equals to 2 to the power n minus 1, right? 2 to the power n is total subsets, and each element is present half of the subset. Each element is present in half of the total subsets, right? 2 to the power n minus 1. Okay. And one thing is clear, that if we want to make a if we want to make a set bit at a specific position, then it should present it should then one should present odd times, right? One should present odd times, right? So if you see here, in this case, why I'm taking XOR, and okay, this should be present at odd times, right? So for that, if you see here, 101, 110, and 001 at a specific position, this is 1, this is 1, and this is 1, right? So if you observe here, this is 1 and this is 1, and at every position, to make a set bit at a specific position, one should present at odd times. But here in this, element is present in half of the times. So don't you think that the result which we are getting after this is 1 1 1, and this, how many zeros can it present? It's 2 to the power n minus 1. Why I'm saying that? If you look at this, 2 to the power n minus 1, so this is something like that every element is present, uh, every element is present at 2 to the power n minus 1. So if you see, if at a specific position any bit set bit is present, it means it will occur in half of the subset values, right? If suppose this is 5, this is one, the one at position, the set bit is present at third position, it means this one will present, this 5 will present in half of the subsets, because just we see now that uh, each element is present in half of the total subsets. So it means if any elements bit is present in elements, it means it is present in half of the subsets. So this one is present in half of the subsets, right? So for a particular element, so this position 1 is present in, so what this position 1 is present in half of the elements, that is this 1 is present in 2 to the power n minus 1. That's the same meaning na. If this 5 is present in half of the subsets, it means its set bits is also set bits are also present in half of the elements, right? So that's why I need to find all the bits which is set for a particular element at a specific position. So I am taking XOR to include all the bits which is set for each and every element. That's why I take a XOR of all the elements to include all the set bits at specific positions, because and for each positions, if this bit is set, it means it is present in half of the elements, so I need to include this 1th position in half of the elements. So for that, each and every set bit will be present in half of the subsets, half of the subsets. So what we can do, I need to take all the subsets which are this here. So and I need to take a summation for all that. So I will just include every set bit for half of the elements and submit it. So for each and every set bit, we have options of half the elements. So for each to the power n minus 1, for this to the power n minus 1, for this to the power n minus 1, right? It means what? Uh, so these are all the options here. These are all the options. So it definitely is the answer of this. This is the result. This is the result for this. So this is what? This is 7, and this 7. If I include this 7 shift what to the power n minus 1, which is equals to 2 to the power n minus 1, which is equals to 7 shift by 2 to the power n minus 1 is what? N minus 1 is 3, 2, that is 2 to the power 4. This is 4. So what will it become now? This will become 28. Understood? Understood? Okay. Okay. Right. Right. So this is 2. So this should be left, not left. This should be multiplied. This should be multiplied, right? So this is 7 into 2 to the power n minus 1. So for every bit I have 2 to the power n minus 1 options. So I need to I need to multiply with this 7 with 4 options, so that will be 28. So how can we write this like this? So if you see here, I need to just shift it by 2 to the power n minus 1 element. So what I will do, I will just shift this with 2 to the power n minus 1. uh, Sorry, we will just shift this with n minus 1, which is 2, right? I will just shift this with 2. It means this 1 1 1 is shifted to 0, and this is the same thing, which is 28 position. If you see here, this is the same thing. So what we are doing here, if you see here also, this 11 is the answer for this. So this is something 3. So for each bit, I have 2 to the power n minus 1 option. That is 2 to the power n minus 1 is here. What? 2 to the power n minus 1 is here is 2 to the power 1, which is 2. So 3, so 3 has every option of 2, it becomes 6. So that's the answer here. So if you see here at 3 left shift by n minus 1 is same thing, right? So it becomes 1 1, and it's shifted by one value. It is same thing as 1, so it becomes 1 1 0, and this is the same as this. So what we are doing here, we are we will we will take odd of all the elements of an array, and and the and the result or value we get after taking odd, that will be shifted by n minus 1 times, right? So that will be the, so let's see, this implementation part is now this. So using this XOR and bit manipulation, we have successfully convert this finding do not find need to I don't need to find all the subsets, and just need to find the odd of all the elements, right? And so why this is working, this is the same thing, like each and every element is present in half of the subsets. So if the bit is set for a specific elements, then it should be present in half of the subsets. So I need to include all the for bit position. So I need to add all this. So I just need to find the odd of all the elements, so that I don't miss any of the bits, and just shift and just multiply it with 2 to the power n minus 1, because it is present in half of the subsets. And that's how I got the answers. So let's implement this. So I just don't need to find all the subsets and taking XOR and add. I just need to find. I just need to make changes for n elements. So what I will do, I will just find odd elements or value. So that will be odd value nums. This should be one, not or no, yeah, this should be 0, because or will shed to 1, right? So this should be 0. So this is how we find the odd value for all the nums. Now what I need to do, this odd value should be the value with 2 to the power n minus 1. So what I need to do, the final answer will be, the answer will be odd value shifted to 1, shifted to n minus 1 part, because this or value will set all the bits, and how many zeros will be left, n minus 1 part, which we have just seen here. In this case, this one is set all the bits, and it just need to shift with n minus 1, so that I can get an answer. Why? Because every set bit has a option of 2 to the power n minus 1. So for 2 to the power n minus 1, it is shifted with n minus 1, because we know 1 less than n is power 2 to the power n. So it's just basically is 1 into 2 to the power n. It is just basically 1 into 2 to the power n, right? It's the same thing, right? So this will be the answer for this. So let's run this, and let's know how will this goes. uh, Expected, something is wrong. This should be n. Okay, let's take this odd value. This should work. Let's run again. Yeah, that was the error, because of this or n equals to, right? So let's submit it. Yeah, we have successfully passed the test, submitted it. So what's the and the space complexity? You will be amazed, right? Let's see. The time complexity will be O of n only. Why? Because we are just taking odd value here. We are just taking odd values, an iteration of O of n times only, and this is O of 1, right? So this is O of n, and the space complexity will be O of 1 only, because we are not taking any extra space. So you do you see that we have gone from 2 to the power n, and from uh, we have gone from here to here, then till here, right? So this is how we optimize the problems. So hope you liked it. I hope you liked it, and comment interested, comment understood, and so yeah, thank you, bye bye, thank you.